Okay, you guys ready? So the test is Wednesday. What are we doing Friday? Something really important, right? Anybody else? Right? Something really big thing going on, right? She's probably here. Okay, ground effect. Let's talk about ground effect. What's the number one thing that ground effect does? Reduces my what? Induced drag. So if ground effect reduces my induced drag, what does that make my aspect ratio behave like?
Higher.
Higher, yeah. So it makes it behave like it has a higher aspect ratio. So how much does my induced drag go down when I'm within one wingspan of the surface? Yeah, about 1%, 1.4%. How about if I get within a quarter of a wingspan of the surface? How much does my induced drag go down? What?
40.
It's not. Well, that's about a quarter. Is that what you just said? Yeah, it goes down by about a quarter. So a quarter of a wingspan, about a quarter of the induced drag goes away. How about when I'm within a tenth of a wingspan? How much does it go down?
Like 70.
Half.
70.
About half, yeah, about half.
Are those numbers you should know?
Wouldn't be talking about it. I didn't think I should. What?
He's trying to read the exact numbers, but it's just like a quarter is fine, right? Like 25%, 50%.
That's what I review right now, 23.5, bonus point. Who can explain interference drag? What is interference drag?
What is it? Intersection of two boundary layers?
That's exactly right. That's exactly what I would write down in the test if I were you. It's the intersection of two boundary layers. For two boundary layers, intermingle, commingle, they interfere with each other.
That was for induced drag?
Yes, sir. No, interference drag. Interference drag. So, what part of the aircraft is most affected by interference drag?
Wing above the wing.
Which part of the wing?
Above.
Or connects to the fuselage?
Above.
Or the wing? Or the what? The upper surface? Is that what you just said? Yes, that's exactly right. The upper surface, because remember, that's where airflow velocities go up, which means then the commingling goes up. Okay, so let's put a total drag curve. Well, I have a steep curve, but you get the idea, right? Okay, so that's my total drag curve. So, what would happen to that curve? Let's say I land on a sandbar, shoot a moose type, and run and take off. Okay, so I just added 400 pounds of weight. What happens to that curve?
Goes
down. What? Up. That's going to go up. So my drag goes up for any given velocity. Remember, a cost gas to carry gas. So any poundage I put in there, I have to pay for by a higher angle of attack. So my drag's going to go up. How about if I'm flying along and I put the gear on? Which direction does that curve move? No hand on the hand side. Hand like say it out loud.
Down.
Down. It goes down. So my drag is reduced for any given velocity. Because I just pulled something out of the slipstream, right? Same thing with closing a door or moving an antenna to an interior portion instead of an exterior. How about if I'm flying along at 7,500 feet and I go to 17,500 feet? Which direction is that curve? Right. To the right. Yes, it moves to the right. Because now I'm flying through a thinner liquid, a thinner fluid, sorry. And so now I get the same amount of lift, or same amount of drag, but at a faster velocity. Less atmospheric drag. What's another word for pressure drag?
Form drag.
Form drag. Exactly right. What could I do to reduce the form drag on my 172? Or
Vortex generator.
what?
Vortex generator.
Vortex generator. I put vortex generators on it. If I decide to streamline an object, when have I gone too far? Can't fly, that's too far. What? When have I gone too far with stretching it out? Say low.
You have influence?
No.
When the weight exceeds, like,
When my skin friction drag increases beyond the decrease in my form drag, is that what you were saying? That's exactly right. You guys are so smart. So when my increase in skin friction drag goes more than my decrease in form drag. So if I stretch that thing out, streamline that, give it a pointy nose and a pointy tail, at some point I'm going to get to the point where my form drag stops going down, my skin friction drag keeps going up. So what's my perfect fineness ratio? 4:1. 4:1. So what happens to profile drag if I streamline an object? Did what? What's that? What's that? Did what? What does it do? It stays the same. Is that what you just said? Yes, it does. It stays the same. Because remember, so profile drag includes both skin friction drag and form drag. So I streamline an object, one goes down, the other one goes up. So profile drag remains constant.
Can you repeat that?
Yeah, so when I streamline an object, so because profile drag includes both skin friction drag plus form drag, so I streamline an object, my form drag goes down, but my skin friction drag goes up. So because of that, my profile drag remains constant. So let's talk about induced drag. So as my load factor goes up, what happens to my induced drag? How much? Squared. That's squared. Okay, so as the load factor goes up, my induced drag goes up by the square. Load factor here in this case would be the same as it goes up by the square. How about what happens to my induced drag if I cut my airspeed in half?
No, it decreases.
Close.
Power of 4.
These mumbles like super pretty. What? For induced drag, what happens to my induced drag if I cut my airspeed in half? No. Goodness, you guys are fast guessers. So I'm going to do this in green because it's not an equation. So remember that my induced drag varies by the inverse of the square of my velocity. So what happens is I cut my airspeed in half? 4 times greater. That's exactly right. So it goes up by the square. It goes up by the square. If I reduce my velocity inverse, that means this goes up by the square. This goes, velocity goes down, that means this goes up by the square. Okay, and the other one was induced drag varied by the square root of that. These are not equations, so just use these to help you on the test. What's another measure? What's another word for the pressure in a given volume? Energy. Energy. Pressure is the energy in a given volume. Okay, so imagine I've got a bowling ball and it's I drop it. Okay, it doesn't matter if it's spinning or not, it's a super smooth surface. So think about all the things aerodynamically that happen with falling bowling ball. Now imagine I turn that into a basketball. What kind of drag would go on?
Skin friction.
Skin friction. What's another word for skin friction drag? Viscous drag. What kind of drag would go down? Right. Take out bowling ball and make it a basketball, try and drag those down, if it's rotating. Think about the guy with the, he did that. They love form drag is going to go down for a normal person. What makes an airplane fly?
Excess thrust.
Excess horsepower. Okay, you got your calculators out? Let's figure it out. Okay, so how heavy is my airplane?
22,000 pounds.
Okay, how fast is it climbing to?
1,500 feet.
1,500 feet per minute. How many excess horsepower does it need?
1,000.
And if I were you, I'd be writing this down, use it as a silly thing. What'd you say?
1,000.
1,000? Anybody else get 1,000?
That's the.
Everybody gets 1,000? A lot of people not. 1,000 excess horsepower. Okay? Now how heavy is my airplane? 3,200 pounds. How fast am I flying? How fast am I flying?
7,000.
7,000 feet per minute.
It's all engine.
All thrust and no rudder, right? Just like my grandson. Sure. He is. He's like crazy. How many excess horsepower does it take to make a 3,200 pound aircraft climb at 7,000 feet per minute? 679. Oh, a lot of people are nodding at that. Anybody lost and no idea what that goofball's talking about? Yes? Yes? Okay, so we take weight times height. Here we take weight times the rate of climb. Multiply those two. Divide by 33,000.
600.
Let me get worse.
8
Okay.
670.
Easy cheese. Nothing to it. Anybody want to do another? Okay, everybody's shaking their head. Don't want to do any more. Okay. All right. So what do we call anything down here?
Acute.
A what?
Acute.
Cube. What's this one?
Right.
Obtuse.
Right? Is that what you got? Yeah. What's over here?
Obtuse.
Obtuse. What's down here?
180.
That would be this one. What's down here?
Airflow.
Somebody said it.
To the reflex.
Reflex. Yeah, reflex. What happens to the boundary layer when, during the adverse pressure gradient?
Source point of person.
It weakens. Is that what you said? It weakens. Doesn't necessarily slow to the point of reversing. Now, if we're stalling, then it will. If we're getting close to stalling, it'll slow to the point of reversing. But in any aircraft, any kind of flying, when you go through the adverse pressure gradient, it weakens. What happens when what happens to kinetic energy of the boundary when the kinetic energy of the boundary layer reaches zero?
Stall. That's
Separates, yeah. Not necessarily stall. It stalls far enough forward. But would I have force interference drag here or here?
Second one.
Second one, yeah. So the smaller the angle, the more drag I get. Okay, I got an airplane that flies 300 knots, and it has a 300 horsepower engine. Just because I thought of nice easy numbers. 300 knots, 300 horsepower. But I really want to go 600 knots. How many horsepower do I need?
2,400.
2,400, that's what I need. Anybody else want to do that?
Just say that one more time.
300 horsepower, 300 knots, I want to double my airspeed. So, if I double my velocity, I have to cube that. 2 times 2 is 4, times 2 is 8. So I take my 300 horsepower times 8 is 2,400. Anybody confused? You want to do another one? Okay, so now I have an airplane that that's 180 horsepower and does 120 knots. So earlier, I think we did this one on Friday or whatever, and I want to go 240 knots. So my multiplier is 2. I cube that. So 8 times 180 would be 1440. 11440. Is that right?
That's correct.
What if I want to go 360 knots? How big of an engine do I need? Pretty big one.
4,860.
What is it?
4,860.
4,860. That sounds right. Yeah. So remember, my multiplier is 3 now, so I'm going to cube 3. 3 times 3 is 9, times 3 is 27, times 180. 4860. Okay. DVV, you got that? Any questions? Good.
So with that power, is that total power or additional power to the 180 horsepower
No, that's total.
total?
Yeah. So if I want to make that airplane move through the air that fast, that's what we need. Okay? All right. Is total energy, is that constant?
Yes.
Yes. Total pressure, is that constant?
Yes.
Yes. Total drag, is that constant?
No.
Yeah. Okay, next semester, you guys are all going to be flying aircraft that have cowl flaps. Anybody not know what a cowl flap is? On the bottom of the engine itself, I push a lever forward, it pops the door open on the bottom, allows for better cooling of the aircraft. Because now I have more air going out, which allows more air to come in, especially in a Seminole where I get 180 knots. So now I have 180 knot wind on that aircraft. Take good care of the engines, because the engines take good care of me, right? So let's say I'm flying along in a Seminole, and I reach down and I close that cowl flap. What are the 2 types of drag that move down? Form drag for sure, because I just pulled that thing out of the slipstream.
Cooling? Cooling?
Not interference. Certainly not induced.
Parasite.
Whatever. If I had a paintball gun, don't ever say parasite. I mean, you can't. It's going to be wrong.
Would it be cooling drag?
It would be cooling drag. Remember, cooling drag is a part of parasite drag. So cooling drag costs us money, costs us energy. So when I look at the parasite drag equation, be this one. What portion of parasite drag equation explains why parasite drag increases with an increase in airspeed?
E
Very
squared.
specific.
E squared.
Just this, right? Here's why I ask that, because sometimes on the test, people will write, well, yeah, we're going to be squared. Densities have nothing to do with it, okay? Nothing. So be very specific if you just happen to be asked that question. What 3 elements change my total drag curve that I raised the most? Weight, altitude, configuration, altitude, you bet. So as I increase altitude, what direction does my total drag curve move? right? Let's say I'm flying along in my Archer and I smoke some meth because I decide to do a loop. Okay, I'm on crack or I'm on something. And I heave back, I go from 1G to 5Gs. How much is my induced drag go up?
25.
25 times. That's right. Remember, I square this. So, let's square the left. 5 squared 25 times. What do you say is another measurement of the energy in a given volume? Pressure, yeah. So if I put laces on a baseball, what kind of drag goes down? Pressure form, yes. Pressure drag, form drag, yep. What kind of drag goes up? What? Skin friction, yes. Otherwise known as viscous drag. What kind of drag goes down if I increase my aspect ratio? Like, let's say, for example, I take an F-104, I pull the wings off, and I put on some glider wings. We're going to take a U2. What kind goes down? Induced. Induced drag.
And that was for aspect ratio going down, correct?
Going up.
That was for aspect ratio going down.
I can't understand a word you're saying. I should have lost my take.
Aspect ratio, is it going down or up on that example?
Its aspect ratio goes up, my induced drag goes down. Because of what?
Sphere of influence.
Sphere of influence. You guys are smart. Okay. We got lots of time left. You guys have any questions on the review sheet that you didn't get?
Go over it again.
What? What?
Why are wingtip vortices included in the strategy?
Yeah, what a great question. I've asked people that for years. Why in the world are wingtip vortices included in this strategy?
Is it because it's taking energy to spit that air?
Yeah, where's the energy come from? Lift. So because wingtip vortices are caused by lift and they take energy out of the offending object, generally the induced drag is caused by lift, but wingtip vortices are a form of drag and they're caused by lift, so they're included in induced drag.
Is it form drag and induced drag?
No, it wouldn't be form drag, but it's something completely different than induced drag, but by definition, that's right.
Oh, because it's byproduct of the.
Yeah, it's exactly right, byproduct, that's exactly right.
Say with it, try
Yeah, what do we say?
Form. Why thrust decreases as velocity increases, aircraft velocity increases?
Yes, it does, but
Relative weight.
because of the new average relative wind of the forward vector. Ask him to explain. You'll draw that. You guys good? Rock solid, ready for Wednesday? And then the big class, remember, on Friday. What's that gonna be for? Okay.
It's Friday.
The big class is ready to ask. If anyone asks, that's gonna be the hardest.
Oh.
Okay, have a great day. Hey, make sure you get your name on the attendance sheet. Back there in the corner. You're not.